All right, welcome to Doozer Shop. What I'm bringing here to you guys today is this new addition to the shop. This was a gift from Jim on Grand Island, the same gentleman I bought the Rockford planer from. So this is a Pratt & Whitney super micrometer is what they call it. And Jim had this, he never told me where he got it, but it's been on his basement floor for a number of years. And basically it's like a 4-inch bar with some kind of hard chrome or something on it, in a tailstock, in a headstock. And this is the first version, I guess you'd call this the A. There's a B and a C, and I think one was with the electro limit LVDT gauging, and then version C had a computer or something. But anyways, how this works, it's a kind of a typical micrometer head. I think it's 50 thou per revolution. You got your graduations there. I'm on 0, and get the glare off of this. So 50 thousandths per rev. I'm not quite zeroed up. And if you go around, there's a vernier adjustment with a with a little side gear that moves the vernier scale. So that's the working end of it there. And it's got kind of a cool stage. Let me kneel down. The stage is like on screw jacks, and you can adjust the height of the stage with the knobs based on whatever you're trying to measure, conveniently or not. And it's supposed to have a gauge tray like a jig bore machine, but I don't have that. But I got a Dual 2-inch standard block that I'm going to play with here. So when I got this, apparently I've seen a few of these because I looked on eBay, and there's a window here, and there's supposed to be an indicating needle and a white background. Well, the white background was a piece of white plastic that had not only turned from white to yellow, it just atrophied into almost dust and cracked apart. So that's gone. And inside here was supposed to be a little lever mechanism with an indicator needle, that would swing on the graduated background, because what this is all about, the tailstock is an indicator for your 0 set, and it's on a couple of flexure leaf springs. You can't see it, but it moves about, I don't know, 5 or 6 or 7 or 8 thou. And what I figured out is, I put it in a bag so it knows the pieces. So this is a spring-loaded plunger that was in there, and it has graduations on it of 1 pound of force and then 2.5 pounds of force. And Pratt & Whitney says if you're using this to measure threads over wires, I think under 20 threads per inch, it's use the 1 pound of spring force measuring force, and above 20 threads per inch, you use the 2.5. But what I did is that thread there is 9/16 diameter, 16 threads per inch. Okay, and what I did is I made another kind of screw-in fitting with that same thread, only a little bit longer in the body, and I eliminated the spring adjustment. And what I did is I screwed in a piece of 3/4 bar that I cut the thread on, and I adapted this Federal, I think it's 2 or 4 thou per rev. But this is my indicator now because this stylus indicator was gone, and just the linkage was gone, and I only know that what the linkage kind of looked like from a picture out of the Pratt & Whitney manual that I found online. So that's gone. Everyone I've seen on eBay, this thing is pretty well degraded and mostly gone. So I had this, and I don't know if a QC department was throwing this out or I got this at an auction or a garage sale. I don't know. But this is a Federal, and you can see it's graduated. You know, 5, it's 0.5, half a thou. 1.0 is 1 thou. So it goes to 2 thou and then back to 0. So I guess this is 4 thou total range. But you can see each tick is half a tenth. You know, the minor ticks are half a tenth, the major ticks are 1/10 of 1,000th of an inch. So 1 thou is divided into 20 to 10 main and 20 ticks if you get it. So measuring a tenth is pretty amazing. Measuring half a tenth, which is the minimum graduation, is freaking awesome. It's just astoundingly accurate. There's those, I think they sweep only 60 degrees millimass, MAR indicators, MAR millimass. I think that's how you say it. And they do some kind of a twisted wire or twisted fishing line or something, you know, real sensitive. But this thing, man, it is very sensitive. I'm going to push on this, and you can watch the needle. I can kind of discern a little bit with my finger, a gentle push. You know, it's all over the map. So ideally what you do is you creep up on the piece that you're measuring, or the gauge block, and you set it to 0, and it's actually got a range of, so that was 0 once, 0 twice. I thought it had more than that. Once, twice, 3 times it'll go around when I push this. And what I did, the spring force, there's a little that comes from the actual gauge, but I put like a 1 pound spring inside here. I could take this off. I should have loosened the screws. It just comes off. It's a lift-off cover with pins. I put a fixed spring on part of the mechanism, so I still have my excuse me, force of a pound. And it's about a pound. I think it's about 1.25 pounds, but it doesn't matter as long as it's consistent pressure. So anyhow, this is a 2-inch gauge block, dual, and so let's, I'm going to kind of show you. So I'm at the upper edge, right, and I can flop it and check it. So this is the hard part. This is the lock for the tailstock, right, and this is the movement. And to get this set to 0 requires a bit of finite finagling with this is a gear rack. There's a rack inside the center of this guy. I'm almost tempted. I want to put a bigger knobby on here, something like at least 2-inch or maybe slightly bigger, whatever I can stand without interfering with. No, I got plenty of room. Yeah, I got plenty of room without touching the body, maybe. But anyways, so let me back up. So let me bring you in, and let me focus on touching here. And this isn't square. You're going to have to fiddle with it a little bit. I'm watching the needle. Oop, see? It's so dang sensitive. So there's pretty close to 0, and then when you lock this, it moves. Alright, so I can, it wants to go down, so I can go, oops, above it. Come on, you. Ah, shoot. It's super sensitive. Alright. So let me lock it and we can adjust the dial. Well, okay, there it's going to stay. Alright, let's see. And this, I guess it's okay, because ultimately you zero out the dial. by turning, turning the face. So that's at 0. And let me play with this. So I'm going to cut with the camera. So I'm sweeping the gauge block to try and get it square. And watch this needle. Oh shoot, wow, hold on. So it's all the way to that side. And I'm minus, what, I don't know, the 3/10. And I'm going to push it to the other side. Carefully, slowly, carefully, slowly. And I'm rocking it. So I'm on that side. So that's pretty good. I probably wasn't square initially. And my point of all this is to say it's a little bit tricky to get set up. Okay, that's 0. Let me push it over there. And my 10th off. I'm wiggling it. I'm almost a 10th off, right there. I'm going to push it back to original, and I can wiggle it back and forth. I'm about a half a 10th off. Okay, so that's not bad. Then you gotta. Okay, that's close. Okay, so there. So that's pretty good. And you're thinking, all right, that wasn't too bad, Doozer. Well, and this is a gauge block of unknown origin. Excuse me. So let me do this. Go here and let me flip it. So I'm on another face. Let me rock it a little. So I'm almost 2/10. Let me rock it, or push it this way. Pretty close. Alright, let me flip it again. So it's 180 now. Let me start there. Half a 10th. 1/10. This is not terrible. This is a third flip. Okay, there you see it, right? I'm 1.5 off. Let me slide it the other direction. Same thing, about a 10th. So let me go back to show you guys. So I went backwards. All right, and I'm heavy by 1.5. 1, and then a tick, a half tick is a, so there, let me go forward again, and I'm shy by 1.5. Okay, let me do it one final time. This is the fourth side, and I'm back up to 0. I can move it, move it, move it. I'm at 0, right? So this gauge block, the faces are out of parallel by 1.5 one way and 1.5 the other way, so that's 3/10 total that these faces are off. And I could lap them a little bit. Maybe it's this rust, right? This is not a new gauge block, right? It's probably just pretty crappy, actually. But, I mean, it feels smooth. It's not like it's, I mean, it feels smooth as all get out. It feels great. But it's of unknown origin, other than it's dual and it's 2-inch. But that's kind of how you do it. You gotta slide it, da-dee-da-da. Okay, so I think that's pretty good. But that's how you use it. And, well, I left out the fact that I should have centered this straight away, first of all. It's close. I'm not gonna. And then this dropped off half a thou. So I'm just gonna, this actually turned out good. Turned out well. There. So that's it. That's how you set it up. So now I can, this is at 0, I can come out 1 inch. So I can measure from 2 inches down to 1 inch with that gauge block set like that. And I suppose I could set it, instead of setting it at 0, I could turn this where the anvil is 1 inch out, and I would 0 at not 0, but 0 at 1 inch. And then I could measure from 3 inches down to 2 inches, instead of now I set it up for measuring 2 inches to 3 inches. Wait, did I say that right? Does that make sense? No, this way I can measure from 2 inches to 1 inch. But if I had preset that not to 0 but to 1, then I could measure from 2 to 3. I had to check my brain with that. So anyways, thank you, Jim, on Grand Island. And I'm not concerned that I don't have adjustable tension. I think having a pound or just over a pound with the spring inside is good enough. But I happen to have this indicator, right? I've got a drawer full of indicators, and I just happen to remember that you know, I had one. I think, yeah, that's about, like, these are pretty good. These are 4, 5, 6, so these are 10 thou per rev, and that was 4 thou per rev. These are nice heavy duty. They're made for like a jig bore. They're super heavy. You know, the case is built to take some shop abuse. And you know, I got ones like this, but that's 10, 20 thou per rev. Incidentally, I was playing, there's a spring here and the cap is missing. I dug the spring out. This is Bendix Corporation. I'm not going to get a great shot, but the calibration date was 1976, right? So I was born in 75, so this was calibrated, you know, 49 years ago, because I'm 50. So that's interesting. Yeah, I saw a spring in there. I think there's a spring-loaded cap that goes on. But anyway, it took a minimal amount of cleanup, and let me kneel down. It's got a bracket on here. I can take that off. But I just made a bar, and I got 2 little 632 set screws to lock on the indicator shank, and that threads in. I should have a flashlight. Hey, wait a minute. Yeah, that's how it goes in there, and there's the mechanism inside there. But that bar, that was the key right there, is make that 9/16 thread on the end and a shoulder, threaded it on a Pratt and Whitney lathe. How awesome is that? And then 2 little set screws to affix the indicator. And you can level it, and it's got feet and whatever. But anyway, I might, like I said, make a bigger knobby for the adjustment of the tailstock, even though you can set the dial. So this can measure to 1/2. And it's 100 pounds, right? It's right at 100 pounds. And I'm assuming that's thermal mass to keep the readings consistent. You know, you're supposed to measure at 68 degrees or something. But anyhow, now that I have the ability to measure to 1/10 of a thousandth of an inch, what is that good for? Well, it's just a handy platform to set my dial gauges for measuring cylinder bores, because you're not, you know, fiddly with everything. And the gauge trough, it would go directly underneath the barrel or the anvil in there, and there's like a little hole in there. But I can't see the gauge trough. So this thing will measure to 9 inches, I believe. So to set it, you need at least an 8-inch standard. Well, I've got, Jim also gave me some standards for my Pratt and Whitney jig bore, my 2A, but they're kind of heavy. They'd be perfect for a gauge block trough, but I want something light to set, 2-inch, 3-inch, 4-inch, 5, all the way up to 8 or 9. I'm thinking, I don't have a set. A set of micrometer setting standards would be great, because they're, I think, a 1/4-inch diameter, I believe, and they're light, so I could put them between centers and center the table, the stage, and not worry about, and they got flat ground ends. The Pratt & Whitney jig bore standards have kind of radiused ends with just a micro flat in the middle, which is not enough to keep it sitting flat and a true straight line. All right, this might be getting a little long, but I just wanted to show you the latest addition to the shop. Thank you, Jim. I probably will never need the 1/2 accuracy. I don't believe that this was graduated, the old needle for centering the tailstock, or making a repeat 0. This is a major improvement. Oh, another thing. On searching eBay, there's a few of these where the whole cover casting was replaced by a unit from Federal Corporation with a little, it's a smaller face, probably a 2-inch face, dial indicator, kind of on the front here somehow. So they made an aftermarket accessory. I didn't know that when I found my indicator, this Federal indicator, and cooked up what I made there the other day. But apparently that's a popular thing to do, because, like I said, after I did this, ironically, I searched eBay, and Federal made a whole replacement cover with their measurement 2-inch indicator built in. And you still retain the adjustable pressure device. But like I said, I just popped a little spring in there of appropriate length and spring rate. It's got about 1 pound of tension. You're just looking for a repeatable force when you're measuring. The amount of pounds or ounces doesn't matter. As long as it's enough to overcome any, friction, and the more spring force you have, the easier this centralizes out. The flats align with the flats, and it becomes a true linear measurement. It's not crooked one way or the other. The more spring tension you have, it wants to straighten itself within reason. But that's kind of neat. There's one of these on eBay, this older Model A, where it was interesting. They put a glass scale linear adaptation to the headstock, and of course a separate readout box, and they put an LVDT inside the tailstock. LVDT is like 2 coils in quadrature, and I think it stands for linear distance voltage transducer, I think. But it's interesting. I just mentioned that because people have been upgrading these for a while with the electronic stuff that the Model B had. And I think the Model C is the same as the B, except it's more of a SPC, computerized statistical process control, where it remembers the measurements. But this is classic design. I love the wrinkle finish, and I just made this thing way more accurate by being able to go, I think this would discern to 1/10, and now I can discern to 1/2. So, whatever, kind of cool, kind of neat. I don't know where I'm going to put this because it's so heavy. I'm thinking I'm going to clean off one of the windowsills, in the back of the shop, and put it there, because I think that would, I know you don't want it in the sun, but it's in the shade side, and there's a tree over the window. It never gets direct sunlight. And for what I'm going to do, heck, man, I don't need 1/2. But thought you guys would find this cool and interesting like I do, because engineers geek out on this stuff, and if there's some other people that are interested, hope you enjoy my content. Till next time, I'll sign off, and this is Doozer Shop.